start off the next topic by getting you guys to go through a short, really simple activity to sort of give you a real life example or visual of what we're going to be talking about. And it's going to help to answer why we place our door handles where we do on a door. So first thing I want you to do is wherever you are right now, press pause and go open and close a door using the door handle. And just get a feel for what that feels like. Okay, and next thing you want to do is you're going to go and open it again, but instead of closing it using the door handle, close it by pressing on it halfway between the door knob and where the hinges are. So if I were to just explain before you hit pause and do this, if you have your door and your door handles here, and let's say your hinges are here, and it's going to swing open and close here. Open your door, but next time when you're closing it, press about here, halfway between the doorknob and the hinge, and tell me what it feels like, or not, you're not going to tell me, but you're going to decide what it feels like in comparison to when you opened it using the doorknob. Does it feel harder to open it and close it, or does it feel easier? And once you've done that, you're going to open the door again. Instead, now you're going to close the door by pushing on it somewhere near the hinge. So where it rotates along this side of the door on the hinges, try to close the door by pressing somewhere here, a couple inches away from that edge of the door. And then decide what you're noticing now. Is it easier? Is it harder? In comparison to where the doorknob is. And this whole activity in itself should just give you an idea of why do we place the doorknobs on the doors where we do. There's a reason for everything, and physics helps us explain that. So now open the door again. This time close the door by placing your hand midway again between the door hinge, but try using different angles at which you're pushing it, and decide what angle seems to work best when you push that door closed. So hopefully what you determined in doing this small activity was if we have a door, and here's my picture of our door here. Let's actually go back to even this one. This is a better one. We place our door handles on one side of the door. And does it matter what side of the door it goes on? Sure it does. Because if we think about this same door here, let's put it up on an angle so we know what ways it's opening. And we have a set of hinges, usually top and bottom of our door. Our doorknob always goes opposite the side of where the hinges are. And so why is that? Is because I hope you noticed in this activity that the further away you are from the hinges, which we have a special scientific term for all the things that I'm talking about right now, but I wanted to give you a real life example first. The further you are from the hinges where it rotates, the easier it is to open and close that door or rotate this around those hinges. And so what you're going to see is the name for this, which I'm going to have on a separate page here for a minute. What we're doing when we rotate something around an object like a hinge, we call this torque, when anything's rotated around something. And this is a factor, so the distance you are away from these two rotational points. And these rotational points are called fulcrums. So the scientific term for the hinges, or the point at which something rotates around, is a fulcrum. And the further you are away, hopefully you determine this from your activity, that the further you are away from your fulcrum, the easier it is, or the more force you can put on it without much effort. Okay, so this is what we're talking about, torque. A torque is the turning force exerted on a rigid object, causing it to turn about its fulcrum. Okay, so if we were to look at the door as an example, this was us pushing on the door. If we were to relate it to what we just did, we were pushing the door closed. We were applying a force to a rigid object, and the rigid object was our door. And we were causing this door to rotate around hinges. And in science, we call that rotational point the fulcrum. So that's the relation to what we just did. And the rules that revolve around torque is the further the effort force, so our effort force was pushing the door closed, the further we are away from the rotational part, the greater the rotational effect. And the greater the force, this one makes sense, the greater amount of force that we apply, the greater effect on the rotation. So the more force, the faster it's going to close. That one makes sense. But this one here is probably new to you. So the further you are away from the fulcrum, or the rotational part, the greater the rotational effect. Okay, we're just going to look at an example together. And so the formula for calculating torque, let's start with that. Just going to make this a little bit smaller here, easier to work with. Okay, so we have torque is equal to the force times the distance. So torque, because we're taking force times distance, and you remember that force is always measured in newtons, distance is always measured in meters. So when we multiply a force times a distance, we end up with a unit called Newton meters. And this little dot here means multiply. It's an extra additional symbol for multiplication. They use a little dot when it's in between two variables or two letters. And this is the unit of torque that we're trying to calculate. So force, this here represents basically the effort to do something, the effort force. So in our example, it was our amount of force of newtons on that door. So this represents the effort force and the distance away from the fulcrum. So that's what you're looking for when you're solving questions like this. Okay, so let's look at an example together. If you push on a door at a distance of 0.6 meters from the hinges, so let's just color code some of this stuff. So 0.6 meters from the hinges, this is telling us our distance. With a force of, so we're using a force of 150 newtons, so now we're being given F. What is the magnitude of the torque produced? So we write down our given information. We have distance equal to 0.6 meters, force is equal to 150 newtons, and they're both in the units that we need. We need them in newtons and meters in order to solve this. Our required is we're looking to try and find torque. So what formula are we going to use? We're going to use torque equals force times distance. And what we end up with is a total of 90 Newton meters. So basically, if we push on the door this far away from the hinges with this amount of force, we end up with a torque force of 90 Newton meters. The magnitude of the torque is 90 Newton meters, so paraphrase it. And one last thing that you guys are going to probably find useful. Remember, every time I said that we have a formula that has just 3 variables, we can use the magic triangle for that. So I'm going to put on here what that magic triangle is, and when we approach our next unit test, this will all be something that shows up on your formula sheet. So when we're calculating for any of these 3 variables, so remember, we're not always just calculating for t, we might have to rearrange and solve. So instead of going through the rearranging process, you're going to have this magic triangle. And remember that down here means we're multiplying, up here means we're dividing. So if we were to create something that we can cover up with, let's do this circle and fill it. And if I were to use this, and let's say we're given our torque. Let's say it equals 50 Newton meters, and let's say we're given our distance, and say that it's 0.5 meters away. Well, what we're solving for now is the force. So you need a rearranged version of this formula. So I'm just going to refresh your memory on how to use this. If we have torque and we have distance and we're solving for force, cover up the one you're solving for. So here I'm going to cover up the one I'm solving for. I'm solving for F, and it's going to tell me what to do with the remaining 2 variables. So F is equal to torque divided by distance because they're separated by a division sign. So therefore, for this one, if we were solving, our force would be equal to torque divided by distance. Okay, and that's it. And you can use that to solve for any of them. If you're given torque and you're given force and you're solving for distance, the one you're solving for, cover up, it'll tell you what to do with those 2 values. Okay, and that's it. You're going to have some practice questions that you're going to try. So give those a try, and then you remember for your practice questions, you always have usually answers to check with those, and these are just for practice so you don't need to submit them for marking.